All right, pop quiz, hotshot. You've got shifts that use immediates that are known to the compiler, and you've got ints. What kind of shifts do you think are going to be generated? If you answered shifts with both an I and a W, you answered correctly. We've got surly W, sray W, and silly W. Yes, it's the return of the silly that we love with a W suffix, so I'm not going to even bother with the build slide here. I'm just going to say it's word sized, so it's RV64I, which means it's always going to be a 5-bit shift because we're treating things as 32-bit registers. And it's a shift left logical with an immediate, an I for an immediate, rather than pulling it out of a register. So concretely, looking at our example, we have silly W, we got T1, T0, and 12. So if we shift it over by hard-coded 12, then we're going to get 0s, 6, 7, 7, 8, 8, and 3 zeros. So shifted by 12, and ultimately sign extended, same as before with the sil W. One more example for good measure, showing that sign extension in action. We're going to shift it by a hard-coded 13 instead of 12. And once again, that means that our upper bit of that 6 goes away from being a 0, 1 to being just a 1. And we're going to use the 1 to sign extend, and we get Fs, C, E, F, 1, 0, 0, 0. And again, you can try this out when you get to stepping through the code by passing in your own shift values. So that is the shift left, and of course the sign extension. All right, surly W, same thing concretely. Let's look at it. We know we're going right. We know it's logical, so it's just going to always be a 0 filling in, and it's an immediate, which is our hard-coded 12, and it's W, so we're only going to consider these bottom 32 bits. So what do we get? We get the zeros right here in the middle now. So this is what's different from the left shift. We're pulling the stuff out of the middle. And so we move it down by 12 to the right by 12. And then it's a logical shift. So we fill in zeros. And of course, that's 0 extension for the other 32 upper bits because it can never be anything but zeros. And our last thing, the sray W. Same thing, we go ahead and we're now here. I'm going to show you the two examples that I didn't show you in the previous videos. So here I am starting with 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and we shift it by 12. So here that 5 gets shifted down along with everything else, and zeros gets filled in for the upper bits because the upper most significant bit, bit 31 of this 32-bit register, was set to 0. So that is what is used for the fill-in of the shift. Sign extension means we get all zeros in the upper 32 bits. Now back to that example where instead I use a 11223344A5 just to force the upper bit to be 1, and they all shift down by 12, and the upper 1 is filled in for that. So nothing should be too surprising here. We're really just dealing with permutations that we've already seen multiple times. So one last time into the breach. This is going to be your last time stepping through the assembly and checking your understanding of these last of the 18 variants of shifts.